Hello everybody, this is Matt with mathsmath.com. Thanks for joining us here today. As we talk about sampling and populations, how do we look at a big group and how do we look at a small group and how do they compare? We're in the Common Core Math Standard of Probability and Statistics, and today we're going to be using samples to guess what the whole population will look like and try to guess what will happen using probability. Our guiding question as we look at this today is how can you make predictions using a sample of a population? Are you familiar with samples or populations? Well, if you're not, you came to the right place. Let's get into it. Could you imagine counting all of the fish in the sea? Well, with math, you can actually get a pretty good estimate. You can take a sample of fish, a sample in a particular area, and extrapolate that out and figure out the total population of fish that will most likely be in the ocean or the sea. The power of math. It's pretty cool. And let's do that. Let's look at that. Let's actually figure out how we can do this. All right, the population of a data can tell us so many things about the group, but sometimes the population is too large, like the population of fish in the sea. You must first take a sample to conduct your research. Let's get a couple definitions down here. Population. Population is the total amount of objects or people or things you're counting in your research, okay? It's the total amount. All right, whereas a sample of a population is simply a smaller group that represents the whole. Okay, so imagine taking the sea and taking a maybe half a mile by half a mile area, and you count the fish inside that group. Okay, now the thing here is that the sample must be random. I can't say, hey, I want that fish or that fish or that fish. Okay, the sample must be random. Now, it must be randomly placed too, to where if I say, hey, I want to do a half mile by half mile section, it's got to be a random section of the sea. Okay, now the other thing, there's a couple more things too. It must be representative of the whole. And by that, I mean it must look like the rest of the ocean or the rest of the sea and the fish. Okay, it must look like the rest of them. And it has to be representative. So it has to have enough in there. And that's our third one, is it has to be big enough to provide accurate results. Okay, so if I wanted to, say, calculate the amount of fish in the sea, I wouldn't take a section of maybe 5 feet by 5 feet. That's just not big enough if the sea is thousands of miles in the square area, okay? So it has to be big enough, it has to be representative, it has to look like the group, and it must be random. Those are the three things that a sample must look like, okay? So when we're looking at samples today, you have to ask yourself these questions. Is it random? Is it representative? And is it big enough? So let's do that. You're going to now choose which group is a population or a sample. Is this the population or the sample compared to this? Are these the population or the sample? Okay. This would be the population, the total amount of building blocks. Whereas this would be the sample. You take just a few blocks together, okay? Let's try it again. These people here at a wedding compared to just this couple. All right. The total group here is the population at the wedding, whereas the couple in the corner is just a sample. Okay, they're just a sample of the total population. Why don't you try to do this one? The state of Colorado compared to the city of Denver. Which one's the population? Which one's the sample? Okay, here's your answers. Now notice we could have done this and said, what about Denver compared to the people who live on Colfax? Denver then would be the population. The sample would be the houses and homes on Colfax. Does that make sense? So really it depends on the two things you're sampling and the two things you're comparing, okay? All right, so choosing a sample, What we're going to call now is called sampling. Sampling is when you make a prediction and that tells us certain aspects about the greater population when you survey just the sample. Okay, so sampling means you collect data from the sample to make a prediction about that greater population. If you're thinking about proportions right now, that's a good thing because when we take a sample, compare it to a population, that's nothing else but a proportion. All right, so let's do it. You'd like to get an idea of how many students at your school ride the bus. Which sample would probably be the best to find out about how many people at the school ride the bus, okay? Now, which of these samples do you think would be good? Which method of sampling? 5 students in the passing period, 15 students in the choir, 25 7th graders, or 50 students at a spirit assembly. Which one of these would represent the whole student body well? All right. Well, of the sample, I think the 50 students would be the best. The 50 students at a spirit assembly means all the students are going to be there, and you're picking them randomly. It's big enough. Hopefully your student body is fairly large compared to the 50 students. All right. So let's actually make a prediction. Let's say we do sample those 50 students at the assembly, and there are 35 of those students who ride the bus. Okay. So you know that there's a total of 280 students in the middle school, though. Okay. So what I want you to do is predict the number as a variable n, of how many students would ride the bus. Well, if you remember, setting up a proportion is really going to help you. You're going to have 35 out of 50. 50 is the 100%. 35 is the part. And then the total now is 280. So what we do is we set up a proportion, 35 over 50, and then we're going to multiply that by 280. Now, notice we reduce 35 over 50 to make it easier on ourselves, 7 over 10. All right, so it becomes, then you've got 10, so 280 divided by 10, which is 28. And then that gives us 7 times 28, which is 196. If you'd like to write a proportion, simply put, you would just do 35 over 50, and then you would do x over 280. Cross multiply, divide by 50, and you'll get 196. Okay? About 196 students ride the bus at your school. You wouldn't have to actually go in and measure the whole student body. That would take way too long. It'd take a lot of manpower, and it'd take a lot of effort on your part. Whereas you could just survey 50. And you get a good, accurate picture as long as it's random, representative, and big enough. Why don't you do this? A survey showed that 860 out of 4,000 households surveyed watched a particular show one evening. Well, there are 100 million households in the U.S. total. Estimate the number of households that watched this show. Remember, set up a proportion, cross multiply and divide, and estimate about how many households watch this particular show. All right, did you get it? Pretty powerful stuff we can use with sampling, huh? You're able to make great predictions about all of the U.S. just by sampling 4,000. If you've ever gotten a phone call or if you've ever gotten an email of a survey, this is how things work. Is they take a sample and then they extrapolate that, make that work for the large population and get a good estimate of what's going on. All right, here's your hint. About 22 million households. All right. Well, can you make predictions using a sample of a population? I bet you can. That's pretty much it as we talked about this. Just imagine now the power that we can use with math of calculating the number of fish in a given area and saying, hey, this is about how much fish we would find in the rest of the sea. Pretty amazing, huh? Well, this is Matt with mathsmath.com. Thanks for joining us here today as we talked about sampling and populations. Check us out on Facebook at Solving Maths Problems or on Twitter, Maths Math, and enjoy math.